Okay, a little bit of work on fractions. So we'll start at the beginning. What is a fraction? Okay, a fraction comes from the Latin word fractus, which means broken. So it represents a part of the whole. It's something that's broken, right? Only part of the whole. For example, I've put an example up there, 4/5, right? Now, the 4 is the number on top, so that's the numerator, and the 5 is the number on the bottom, so that's the denominator. Numerator on the top, denominator on the bottom. Okay, there are 3 types of fractions. If you look up there, first one is proper, second is improper, and the third one is mixed. So we'll go one by one, just a short explanation on each type, and then we'll do examples of each type, right? Okay, so the first one we're doing is proper fraction. Okay, in a proper fraction, we only have part of the whole. So the numerator is smaller than the denominator. Just like what's shown up there, the number on top is smaller than the number at the bottom. So this sign here, the thinner side, points at numerator, so the numerator is smaller. The big open, the mouth of it, it is pointing to the denominator. So the denominator is bigger than the numerator, or the numerator is smaller than the denominator. Okay? So what happens when the number at the bottom is bigger? The value of the fraction is less than 1. So the value of the fraction, of a proper fraction, is less than 1 because it is only part of the whole. It is not the whole, it is only part of it. So, for example, if we had, let me draw here, if we had a whole circle, say that is the whole, okay? I'm doing a graphic illustration of this fraction. So say the whole is split into 2 parts. So the bottom shows how many parts the whole is split into. This is the whole. If we split it into 2 equal parts, but on top shows how many of the parts of the whole is actually represented by the fraction. So there are 2 possible parts, but here we only have 1 of the 2 parts. So only 1. So I've only shaded 1 of the 2 parts. And so the shaded part represents what this fraction, the value that this fraction is showing. Okay? So this fraction is a half. And you see the picture, it is a half, or only 1 of the 2 possible parts. Okay, let's have another representation. I have a full circle here. I split it in half and then again in half. This is it's not perfectly drawn, but I've split the whole into 4 equal parts, right? So the denominator is 4, because out of the whole I have 4 possible equal parts. Now, if this fraction was, say, 3/4, then I will shade 3 parts out of the 4. Only 3 parts out of the 4. So it is only a part of the whole. It's not the full thing, just a part of it. 3 parts out of the possible 4. up here, 1 part out of a possible 2. We'll show another one. Say here. Say I've split it into 3, right? So the denominator is 3 because there is a possible 3 parts. Say I only am shading 1, so it's only what's being represented by this fraction is only part of the whole, and it is only one of the 3 possible parts of the whole. Fourth example, say not only do I split it into 4, but each of the 4 I split into 2. So now there are, can you count? 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts. So the denominator is 8, because there are 8 possible of the equal parts. If I shade only one, 2, 3, and another one here. So it's 1, 2, 3, 4, right? 4 out of the possible 8. So that is the last example, 4 out of 8. That's another fraction, only 4 pieces out of the possible 8 pieces that make the whole. On to the second type of fraction, which is improper fractions. So I have up here improper fractions. We have more than the whole. Remember, with proper fractions, we have less than the whole. The second point is that the numerator is bigger than the denominator. So the number on top is bigger than the number at the bottom. And the third thing is the value of the fraction is more than 1. So these are all opposite to proper fractions. So proper fractions, we had less than the whole. Improper, more than the whole. Proper fractions, the numerator was smaller than the denominator. In improper fractions, the numerator, number on top, is bigger than the denominator. And then the value of the fraction. With a proper fraction, it is less than 1. With an improper fraction, it is more than 1. So this is because it's more than the whole. The whole is equal to 1. So let's draw some examples. So for example, okay, the whole, say the whole is represented just like before by a circle. Say we split the circle in 2, right? And the fraction we are showing, because the whole is split into 2, our denominator is 2. Not showing up very well. Denominator is 2. So, yeah, the wholes are split into 2. Now, out of the possible 2 of each of these, say I have shaded 1 there, 2, and 3 on this side. So 1, 2, 3 out of the 2. 2 is for the whole, but improper, it is more than the whole. So it's more than just 1. 1, 2, 3 parts out of the 2. All right. The ink is not showing all that well, but it's 3 over 2. So out of a possible 2 in the whole, we have 1, 2, 3. Let's have another example. Okay, 2 circles there. Say we split them into 4 equal parts, right? So each circle is split into 4 possible parts. Denominator is 4. Each whole has a possible 4. Say I then shade a number. But I have to shade a number more than 4 because it's an improper fraction we're looking at, and the number on top is always bigger than the number on the bottom. So 1, 2, 3, 4, 5, 6, 6 over 4. Okay, whiteboard markers are beginning to slip and slide. Okay, 6 over 4. So out of the possible 4, out of each whole, 1, 2, 3, 4, 5, 6. 6 over 4. Improper fraction number 2. Okay, if we were to go on, show another example. That's me trying to split it into 3 equal parts. So one whole is split into 3 possibles. So the denominator is 3. But the number of parts that I'm shading is 1, 2, 3, 4, 4, right? 4 over 3. That's another improper fraction. The number on top is bigger than the number on the bottom. You see, with these fractions, 1, we have more than the whole, because the whole is basically 1. Or 1, or even 2 or 3, whatever, but more than at least 1. So the whole is when the number on the top is equal to the number on the bottom. That's 1. More than 1, the numerator is bigger than the denominator. The value of the fraction is more than 1. So this is the 3 graphical examples of improper fractions. We can go on to the third one. On to the third type, which are mixed fractions. Okay, mixed fractions. Now, mixed fractions, we have more than the whole. This is one similarity it has with improper fractions. More than the whole. So the value is more than 1. And it has a whole number and a fraction. So for example, 1, that's the whole number, and a fraction. So you'd say this, so you'd read that out as 1 1/4, or 1 1/4. And here, 2 1/2. Here, 1 2/8. If we were to put it in terms of a picture, over 4, like the examples we were doing before, so the whole is split into 4 possible parts. I've done 2 here because first you have 1, so 1 whole. I will color all of that. And then the second one, out of the 4 possible, I will only color 1. All right? So 1 1/4. So 1, I will shade all 4 quadrants. 1 shaded, second one shaded, third one shaded, fourth one shaded. That makes up 1. 4 over 4 is equal to 1. Here, out of the possible 4, I'm just shading 1. Right. 1 and 1 over 4. Let's move on to the second one. 2.5. I've put 3 circles here because first you've got to get the 2. Those will be completely shaded. And then the last one, out of the possible 2, you have 1. So just like the one before, we're using the denominator of 2 here to split the 1 into 2 possibles. 2 possible portions of that one. Right? 2 wholes. So I will... So 2 out of the 2, that's 1. Second one, I'm shading both parts as well. 2 out of the 2, 2 out of the 2. So 1 plus 1. And now we're down to the half. So that's only 1 out of a possible 2. 1 out of a possible 2. Now 1 and 2/8. Final example. Because 8 is the denominator here, I've split each of these circles into 8 equal parts. Well, roughly equal. I can't draw perfectly here. So 1, I will color all 8 parts or shade all 8 parts. Right, all 8 parts are shaded. That's 8 over 8, and it also is equal to 1. Now the second part of it, 2 out of 8, so I'm only going to shade 2 parts out of the 8. Doesn't matter which 2, but I've shaded 2 out of the 8. So that's just to show mixed fraction, a graphical explanation, graphical illustration of mixed fraction. Now, one of the things that you will see here is these drawings are very similar to the drawings I did for improper fractions. And that's true because you can express this mixed fraction also in terms of an improper fraction. So you can make it both, you can make the whole number just be a number, a numerator over 4 with no whole number. And we'll move on to that later. But for now, this is the simple form of showing it. One part is the whole number, and the second part is the fraction. Okay. Now, when you're discussing this one, the first one, proper fraction, value was less than 1. Improper fraction, value was more than 1. And mixed fraction, again, the value is more than 1. So it makes you ask, 1, what exactly is 1? Well, like we were showing before, 1 is where the numerator is equal to the denominator. So any number over the same number is equal to 1. If I rub this out and just put a couple of examples here, so you are in no doubt of what is equal to 1. 1 is equal to, I can pick any number, 25 over the same number, 25. That is equal to 1. Also equal to, pick a small number, 3 over same number, 3. That is equal to 1. Slightly bigger number, say 10 over 10. Still, any number divided by itself, it's equal to 1. So any number over the same number, so when the numerator is equal to the denominator, that's equal to 1. Let's put 1 million, 1 and 6 zeros after it, over 1 and 6 zeros after it. 1 million over 1 million. Guess what? That's Still 1. Okay. Now we'll move on to something that's related to this, because I have shown you a whole series of fractions. These are all different fractions, but they all have the same value, and that is 1. The value is 1. So all of these are equivalent fractions. That leads us on to the next part of this, which is equivalent fractions. Okay, on to a quick explanation about equivalent fractions. So equivalent fractions are where the numerator, as I mentioned before, the numerator and the denominator, so the number on top and the number on the bottom, might change, but the value of the fraction remains the same. And I'm going to show this, illustrate this in this 4 different diagrams, which will have the same value. Okay, so the first one, you'll see let's see if I can minimize that light. Okay, well, the circle is split into 2. Here the circle is split into 4. So split into 2, so the denominator here is 2. Denominator is 2. Here the denominator is 4. Here the denominator is 6, because there's 1, 2, 3, 4, 5, 6 different parts there. And here 1, 2, 3, 4, 5, 6, 7, 8. 8 different parts. This is to illustrate that the same value of that whole circle, or the same portion of that whole circle, will be shaded in each of these examples, but they will have different fractions. The numbers might be different on the bottom and on the top, but the value of the fractions remains constant. The value is the same. Okay, so what I will be doing in all 4 examples is I'll be shading only the top half, right? The top half of the circle. Okay. So here, out of the possible 2 parts, I'm shading only 1. So it's represented by 1 over 2. So here, the second example, I'm shading 2 parts. 1 and 2 out of the possible 4. So 2 out of the 4. Still only shading only the top part. Here I'm shading 1, 2, 3. 3 parts out of the possible 6. 3 over 6. And the last one, I'm shading 1, 2, 3, 4 out of the possible 8. So 4 out of the possible 8. Each of these fractions are equivalent. They have the exact same value. All of them express the same value, which is half. And half is expressed in its simplest form here. This also means half, and so does this, and so does this. So 4 over 8, 3 over 6, or the number on the top is half of the number on the bottom. Number on the top is half of the number on the bottom. That means the number on the top, you times 2, you get the number on the bottom. So any fraction, the number on the top, you times 2 to get the number on the bottom, that too will be equivalent to these 4 fractions, because they will all have the same value. They will all be only shading off half of the whole. Okay, I hope that's clear. Now let's work through a few examples of how to get an equivalent fraction and how to get it by calculating a specific denominator or a specific numerator. Now, we've already said before that any number that has the same numerator and the denominator, so same number over itself, for example, 10 over 10 or 3 over 3 or 1 over 1, that is equal to 1. And any number multiplied by 1 or divided by 1 is equal to itself. So to illustrate this, for example, if I had the number 4, say if I had the number 4 over 7. Say I had the number 4 over 7. If I multiply that by 1, it still will be equal to 4 over 7. So whatever fraction I put here, as long as it's 1, same number on the top, same number on the bottom, then this equation will still be true. That side of equals will still be equivalent in value to this side of the equal sign. Right. Draw the equal sign again. Right. So say we put 2 over 2. If you multiply a fraction by another fraction, we'll go into the rules for fractions later. Just multiply the top. 4 times 2, that is equal to 8. 7 times 2 is equal to 14. So 4 over 7 is equal to 8 over 14. They're equal because the numbers on the top and on the bottom might be different, but the value is the same. They are equal in value. So you can change any fraction to another equivalent fraction, to another fraction of the same value, by multiplying it by 1 with the same number on any same number on the top, any same number on the bottom. Okay. Now say we are trying to fill in the blanks. So say we start with the fraction 3 over 4. And someone has given you 8, and you are supposed to come up with the number on top. Now, what have we learned from up here? Whatever you multiply by the bottom, you also multiply by the top. Then the answer will come up to an equivalent fraction. So how do you get from 4 to 8? Whatever you multiply by the bottom, you should also multiply by the top, because that'll be equivalent to multiplying by 1. And it'll give you an equivalent fraction. How do you get from 4 to 8? Multiplied by 2. So multiply by 2. Let me write that a bit clearer. Multiply by 2. So you will naturally multiply by 2 to the top here too. 3 multiplied by 2 is 6. So 3 over 4 is equivalent to 6 over 8. What if now they give you, say, 12, and they're asking you, what do you put on the bottom? You look at the top. You can either start again from this 3 or start from this 6, whichever one is easier for you. Here, this one is probably easy. 6 times 2 is equal to 12, yes? So times 2. So if you do the times 2 on the top, then you must do the exact same thing on the bottom, times the same number on the bottom. Times 2 8 times 2 is 16. over 16. Now say you have another problem here. Say it is 9. And they're asking you, what is the number on the bottom? Just look at these numbers here. Which one is easy for you to convert to 9? 3? 3 times 3 is equal to 9? Yes? So 3 times 3. If I'm going from there, times 3 is equal to 9. Then I'm going to go from here to, from the 4, times 3, 4 threes are 12. And that will be my denominator. So 9 over 12. So all of these are equivalent fractions. 3 over 4, 6 over 8, 12 over 16, 9 over 2, 12. Sorry, 9 over 12. Now, we're showing multiply by 2, but the reverse is also possible. So you can divide a number, as long as you divide the same number on the top as on the bottom. Because any number, if you multiply it by 1, it gives you the same number. If you also divide it by 1, it also gives you the same number. Doesn't matter if you're multiplying or dividing. So you can go backwards. You can divide the numerator, but also divide the denominator by the same number. Whatever you do to the top, you do to the bottom. If you multiply by 2 on the top, multiply by 2 on the bottom. If you divide by 3 on the top, divide by 3 on the bottom. Okay? Say we were to start at 12, and say we were dividing by 2. So say we're going from 12, divide by 2. That's a nice easy one. 12 divided by 2, 6. So the bottom, the denominator of that same fraction, where the 12 is on top, we take the 16, divide by 2. 16 divided by 2 is 8. 8, so 6 over 8. We're returning again to the 6 over 8. But I'm just showing you the interrelationship between equivalent fractions. You can come up with any number on the bottom, any number on the top, as long as you're doing the same thing to get the new numerator as you are to get the new denominator. You want to change any fraction to an equivalent fraction. If you're going to multiply by 2 on the top, multiply by 2 on the bottom. If you're going to divide by 10 on the top, divide by 10 on the bottom. How about we do that particular example? Okay. Divide by 10. I said divide by 10, right? Say we start with 10,000 over 6,000. 10,000 over 60,000. 60,000 is 4 zeros, 10,000 is 4 zeros. Okay. Say if I want to divide by 10 on the top to get an equivalent fraction, guess what? I've got to divide by 10 on the bottom as well. What's the easy thing to do to a number that has 0 on the end? Divide by 10, you just take off 1 0. Very easy way to do it. So all I do, instead of 4 zeros, I now have 3 zeros. So 1, 2, 3. Same thing on the bottom. I lop off a 0 on the bottom. So 6, instead of 4 zeros, I just put 3 zeros. These two are equivalent fractions. They have the exact same value. What about I divide it by 10 again? Both the top and the bottom. Take off an extra 0. Now we're down to 2 zeros. And the bottom, take off an extra 0. 100 over 600. Exact same value. It's an equivalent fraction. Let's take off another 10. Divide by 10, sorry, another 0. So divide by 10. 10, we're now down to only 1 0, and 60. 10 over 60. Guess what? It's the exact same fraction. It's the exact same value. It's an equivalent fraction. We'll take it through to its simplest form now. Take off another 0. You end up with no zeros now. Just the 1 is left. And here, just the 6 is left. That is its simplest form. That is this fraction in its simplest form. But all of these, 1 fraction, 2 fractions, 3 fractions, 4, 5 different fractions, they all are equivalent fractions. They all are the same value. Equivalent fractions. Before we finish up on this small explanation on equivalent fractions, let's quickly just do 2 examples, well, 2 line examples. Okay, if you start off at 1 over 5, how do you get to 10? 5 to 10, fairly simple, times 2, right? 5 times 2 is 10. Do the same thing on the top. 1 times 2, 2 over 10. Now you got the first one. To get to the second one, 3 on the top. Start again with the 1. That's in simplest. 1, how do you get to 3? Times it by 3, right? Because you're either multiplying or dividing. So here you're multiplying by 3. Multiply by 3 on the top. You must also multiply by 3 to get the number on the bottom. So 5 multiplied by 3. 5 3s are 15. 5 3s are 15. Right. Now to get to 4, start again at the front, the first fraction. 1 to get to 4. Multiply by 4, right? 1 times 4 is equal to 4. So you do the same thing on the bottom, times 4. 5 times 4 to get the bottom. 5 times 4 is 20. 5 4s are 20. Get the number on the bottom. Now, don't get confused if a fraction is repeated. Just recheck you've done everything correctly. So now you've got 20 on the bottom. You can copy this 4 and put it there because 4 over 20 equals 4 over 20. If you know already that the denominator is 20, then you know the top has to be 4 in order for these two to be equivalent. But if you want to start again how you worked it out, so 5 multiplied by what to get 20? 5 4s, so times 4. So 1 times 4 to get the top. Right, so here, even whichever way you do it, whether you copy the answer from here to get this, not so much the answer, we'll copy the solution here to get this 4, or you work it out again from the beginning, just like we did the others, we'll end up with the same. Okay, second one, 2 over 3. Let's find out the other equivalent fractions in this problem. 3 to get to 6, what do? Multiply by 2. Remember, you're only multiplying or dividing. You're not plussing or minusing anything here to get equivalent fractions. Multiply by 2. So the top, you must also do exactly the same thing. Multiply by 2. 2 multiplied by 2 is equal to 4, right? 2 2s are 4. Got your first answer there. Okay. These whiteboard markers like to misbehave, so we've got 4. Now, how do you get to 9? 3 times what is equal to 9? 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 times 3. So times 3 the top as well. 2 times 3 is 2 threes are 6. This time you've got the numerator. 2 times what gives you 8? 2 what's are 8? 2 fours are 8, right? Times 4. So the bottom, you must also do the same thing. 3 times 4. 3 times 4. 3 fours are 12. I got my number for the bottom. Final one, we've got the denominator, it's 15. 3 to go to 15. 3 times what is equal to 15? 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12. 3 fives are 15. Times 5. 3 times 5 is 15. So the top you must also times 5. 2 fives, 10. All of these fractions might be expressed differently, different number on the top, different number on the bottom, but they all have the same value. They are all equal in value.